Assalamualaikum and good day. My name is Nordini and I will be the first presenter for this topic. In this part, I will explain the basic concept of entropy and its relation to the second law of thermodynamics. In thermal physics, entropy is a very important concept because it explains the natural direction of physical processes. Entropy is not simply disorder, but a measure of how energy is dispersed within a system. Through entropy, we can understand why some processes occur naturally, while others are impossible without external intervention. Entropy, denoted by the symbol S, can be understood as a measure of disorder or energy dispersion in a system. A system with low entropy is more ordered, while a system with high entropy is more random. For example, ice has lower entropy than water because its molecules are arranged in a more orderly structure. The second law of thermodynamics states that the entropy of an isolated system never decreases. This means natural processes always proceed toward increasing entropy. Because of this law, time only moves forward and cannot reverse. For example, ice melts into water at room temperature. However, water will not freeze back into ice on its own without external assistance such as a refrigerator. This is because melting increases entropy, while the reverse process will require entropy to decrease, which violates the second law.
Now, let's talk about entropy in heat engines. Entropy is a measure of energy spread or disorder. When heat flows from a hot reservoir to a cool reservoir, entropy always increases. In a heat engine, the engine absorbs heat from hot reservoir. When some heat is converted into work, the remaining must be rejected to the cool reservoir. This rejected heat increases the entropy of the surrounding. That is why entropy generations cannot be avoided in real heat engines, because entropy must be increased. It is impossible to convert all heat into work. This is a key reason why heat engine can never be 100% efficiency. Can heat engine operate without increasing entropy? No, entropy increase is unavoidable. What is a heat engine? So first, a heat engine is a device that converts thermal energy into the mechanical works. In simple words, it stays in heat and produce useful work, like turning a turbine or moving a piston. The heat engine receives heat Q from a hot reservoir at a high temperature, which we call TH. Part of this heat is converted into mechanical work, W. However, not all the heat can be converted into work. Some heat, called QL, must be rejected to a cool reservoir at a lower temperature, TL. Heat naturally flows from hot to cool, and the rule of the heat engine is use part of the energy to do useful work. Because some heat is waste, entropy will increase, and this entropy generation is unavoidable. What is the main purpose of the heat engine? Of course, to convert heat into useful work. Does heat engine use only one temperature source? No, it needs both hot and a cool reservoir. At this slide explain how the second law of thermodynamics affects heat engine efficiency. The second law states that a heat engine cannot convert all absorbed heat into work. Some heat must always be released to the surroundings so that entropy increases. That is why the efficiency of a heat engine is always less than 100%. In real engine, efficiency is even lower because of losses like friction, heat leakage, and irreversibilities. An engine can only be 100% efficiency if QL equal to 0, meaning no heat is rejected to the cool reservoir. But this situation is physically impossible because it would violate the second law. So, in reality, entropy increase limit the maximum efficiency of a whole heat engine. So, can heat engine be 100% efficiency? Of course no. Why not? Because some heat must be rejected to increase entropy. What happened of the efficiency in real engine? It is always less than ideal due to losers.
In daily life, we can observe entropy everywhere. A tidy room becomes messy if left untended. Phones and laptops heat up during use because energy spreads into the surrounding. Entropy is closely related to the arrow of time. We can remember the past but not the future because entropy is always increasing. If entropy could decrease naturally, time could flow backward, but this is impossible. On a cosmic scale, the universe is also experiencing an increase in entropy. The heat death theory suggests that one day the universe will reach a state of maximum entropy. At that point, there will be no usable energy left to perform work. In conclusion, entropy is not just a theoretical concept, but a fundamental law that governs the universe. It determines the direction of time, limits engine efficiency, and influences our daily life. Entropy reminds us that every process has an unavoidable cost.